This is the video for section 5.4 notes, slides 20 and 21. All right, so it says if f of x equals 4 plus 2, square root of 4 plus 2 sine x, find the linear approximation of f of point 1. All right, now point 1 is a value that is near x equals 0, right? And so what we want to do is we want to write the equation of the line near or at x equals 0 to in order to approximate this. All right. So step one here, write equation of tangent line at x equals 0. All right, so x equals 0 means what? Well, 0 comma what would be the y value. So we evaluate f of 0, right? So f of 0 is the square root of 4 plus 2 times the sine of 0. Sine of 0 is 0, so 4 plus 2 times 0 is 4 plus 0. So square root of 4 is 2. So our point is 0, 2, right? So now we need the slope. All right, so the slope of the tangent line, right, remember, is going to be f prime of 0. All right, and so we need to find f prime of x first. So derivative of this would be 1/2 times 4 plus 2 sine x to the negative 1/2 times the derivative of 4 plus 2 sine x, which would be 2 times the derivative of sine, which is cosine x. All right, so now we want to evaluate f prime of 0, right? So f prime of 0 is 1/2 times 4 plus 2 times the sine of 0 to the negative 1/2 times 2 times the cosine of 0. All right, so sine of 0 is 0. So really I have 1/2 times 4 to the negative 1/2 times 2 times the cosine of 0. Cosine of 0 is 1. All right, and so I have, well, 4 to the negative 1/2. That means 1 over the square root of 4, which is 2 times 2, of course, so the 2 is reduced. So we're left with 1/2. So the slope of the tangent line is 1/2. So I write my equation, y minus 2 equals slope of 1/2 times x minus 0. Sorry, I wrote 2, 0, right? Or y equals half of x plus 2, right? And so now step 2, we want to plug in our value. So f of 0.1 is going to be approximately equal to the value of y. And y is going to be half of x, which is 0.1 plus 2. So half of 0.1 is 0.05 plus 2. So that means f of 0.1 is approximately 2.05, right? So that is our linear approximation of the value of the square root of 4 plus 2 sine of zero point 0.1. All right. Now you could go ahead, you could like plug that into the original function and see that this is approximately equal to 2.05, right? So that's nice, right? That's all we're doing here. Now, this is not a terribly AP like question though, right? Because if I wanted to know that value, wouldn't I just like plug it in, right? Couldn't I just use a calculator? We don't really need calculus to do that, right? But here, the next question is much more AP like. It says let f be a differentiable function such that f of 3 is 4 and such that f prime of 3 is 2. Use a tangent line to approximate the value of f of 3.1, right? So now we don't have a function that we could plug 3.1 into. The best we have is to use this tangent line, right? And so what we want to do is we want to, so step one, we want to write the equation of the tangent line at, well, it would be at x equals 3, right? Right? Because that's the x value that we have, right? And so that point is 3 comma 4. We're given that, right? And then we want to use the slope of the tangent, which we're given to be f prime of 3, which is 2. So what is the equation of our tangent line? Y minus 4 equals 2 times x minus 3, right? So now here's our tangent line. And so then what we want to do is we want to plug 3.1 in for x. And so y equals 2 times 3.1 minus 3. And then I bring the 4 over, right? So this is the value of y. So f of 3.1 is approximately equal to the value of y, which is what? Well, 3.1 minus 3 is zero point 0.2. So 2 times zero point 0.2 plus 4, right? So 2 times zero point 0.2 is 0.4. So we get 4.4. right? And so that is our approximate value of f of 3.1 based upon the information that we're given. All right. And so that is slide number 20.